Hi, welcome back. In this video, we're just going to introduce the dot product in R2, R3, and Rn, n dimensions, and talk about where it came from, why we need it, and remind you of a few things you already know. So first of all, you already know how to get the length of a line segment in R2. A vector is just a line segment, a directed line segment in R2, and it has two components. And we can use the distance formula or the Pythagorean theorem, and we can figure out what the length of that line segment is. In this picture, it's the square root of x squared plus y squared, the square root of the sum of the squares of the two components of the vector. And we call that the length of the vector or the magnitude of the vector, and we use sort of double absolute value symbols to denote magnitude or length or norm. So in Rn, we'd like something similar. So this notion of taking the sum of the squares of the individual components and then taking the square root of that is how we're going to define the length of a vector in Rn. So I've got a vector v in Rn. It's got n components. And if I want the length of the vector, I'm just going to call it the square root of v1 squared plus v2 squared plus v3 squared up to vn squared. Notice that the sum that's inside the radical is a non-negative number because it's a sum of squares of a bunch of real numbers. And notice also, it's only going to be 0 if every single one of those components was 0. So the only vector in Rn that can have length 0 is the 0 vector. Every other vector has positive length. Also, if we want to know the distance between two vectors in R2, let's say we have this vector x1, y1, and another vector x2, y2. To get the distance between them, we take the length of this vector, the first vector minus the second vector. We just take the length of the difference. And so the distance, and also using the distance formula, it's the same thing. It's going to be the norm of that vector, which always turns out to be the square root of x1 minus x2 squared plus y1 minus y2 squared. It's the same as the distance formula or the Pythagorean theorem. So to do that in Rn, we do the same thing. So what we're going to do is we're going to define something called the dot product in Rn. The dot product is just going to be the sum of the squares of the components, or the sum of the products of the components. So if we take the dot product of two different vectors in Rn, v and w, two different vectors, the dot product is just going to be the sum of the products of the corresponding components. So it's v1 times w1 plus v2 times w2 plus v3 times w3 up to vn times wn. That's the dot product. So then if we want to know the length of a vector, we take the dot product of the vector with itself and then take the square root of that. Or if we want to know the distance between two vectors, we subtract the vectors and then find the length of that vector. What about angle between vectors? The dot product actually allows us to define the angle between vectors in n dimensions. So even though we can't draw the vectors, we can find the angle between the vectors. If you have two vectors in Rn, u and v, the angle theta between the two vectors, u and v, is defined by this equation. Cosine of that angle is going to be u dot v divided by the length of u times the length of v. So that's a real number, it's a scalar, because u dot v is a real number, and the length of u is a real number, and the length of v is a real number. And now theta always has to be between 0 and pi. So note that this fraction is always between -1 and +1 by the triangle inequality, which is in our textbook. It's an easy theorem to read, and it makes sense if you draw the triangle. So the numerator of this fraction is always less than or equal to the denominator. So you're always going to get a number between -1 and +1. And so it makes sense to define the cosine of an angle to be that number. All right, let's use that in an example. So in this example, we're going to find the angle between the vectors u and v in R4. So this is in 4 dimensions. We cannot draw the picture, but we can find the angle between the two vectors. So according to our definition, the cosine of the angle we're looking for is u dot v divided by the length of u times the length of v. So using the definition of the dot product, we take the sum of the products of the corresponding components. So the first components are u and are 0 and 3. So it's 0 times 3 plus 1 times 3 plus 0 times 3 plus 1 times 3 all over. Now the norm, or the magnitude of u, is going to be the square root of 0 squared plus 1 squared plus 0 squared plus 1 squared. And the magnitude of v is the square root of 3 squared plus 3 squared plus 3 squared plus 3 squared. And so if I simplify that, the numerator is going to be 6. The denominator is square root of 2 times the square root of 36. So I get 1 over the square root of 2. So that's the cosine of the angle I'm looking for. And I know the angle I'm looking for is between 0 and pi radians. So theta is the arc cosine of 1 over root 2, which means that it's pi over 4 radians. So that's just a basic introduction to the dot product in Rn and where it comes from and what we need it for. And you'll see in later videos and in your textbook and your exercises several really important properties of the dot product and some theorems about the dot product. And then in the next section, we'll learn how to generalize the dot product to any vector space on which we can define an inner product. And I'll see you in some later videos.